Hello, speakers. Greetings and welcome all to our Tech Talk session today, seeing through the smoke, building network resilience with satellite imagery and AI. Over recent years, climate events have not only increased in frequency but in complexity. From the devastating Black Summer bushfires to the recent floods in Queensland, the urgency for smarter, faster, and predicted tools have never been clear. That's precisely what our session is about today. I'm Ujjwal Sonawne, and I will be your host and moderator today, representing Tech Mahindra and the Altavec platform. Altavec is a leading software solution helping industries unlock the power of their data with geospatial intelligence and AI. And today we are going to discuss how organizations are using satellite data, LiDAR, and AI/ML to better prepare for, respond to, and recover from bushfires, wildfires, and extreme climate events. And this is a very crucial conversation for anyone in utilities, transport, or government, whether you are responsible for critical infrastructure or managing community safety. Understanding how to embed geospatial intelligence into your strategy is becoming non negotiable. Now, let's take a moment to reflect on what that means. So, in Australia alone, we have seen how bushfires can devastate entire regions, disrupt transport, and threaten lives. But we have also seen how data, when used well, can help us anticipate, prepare, and respond more effectively. And that's why this conversation is so timely and important. And each of our speakers bring a unique perspective today, from business strategy to technical implementation. And as we go through today's session, I encourage you to think about how this might apply to your own organizations or to your industries or to your regions. So now joining me today are three of our industry and solution experts. David Matthew, who heads the utility business ANZ for Tech Mahindra. Daniel Pendlebury, who is the business development manager at Tech Mahindra Altavec. And Anthony Wilson, who is the sales engineer at Tech Mahindra Altavec. So now over the next 40 minutes or so, we will explore real world examples, discuss current challenges, and share practical steps to boost your organization's resilience. And there will be also time at the end to do Q&A, so please feel free to drop in your questions in the chat at any time. Now, to kick things off, we will hear from David Matthew, who has been working closely with utilities across Australia and New Zealand. And he will also help us to understand why resilience is no longer optional and how the risk landscape is evolving. So now I will hand over to David to discuss the challenges and the changing risk landscape. Over to you, David.
Hey, thanks, Ujjwal. Let's start with why this conversation is absolutely critical. Over the past decade, we've seen a dramatic rise in climate related disruptions, and especially fires. In Australia, the Black Summer bushfire of 2019-20, if you remember, destroyed over 3,500 homes and burnt an area roughly equivalent to the size of Ireland, or maybe 1.5 times that of Switzerland. And this showcases the devastating scale of these events. These fires are part of a trend of increasing fire intensity and complexity. Fire seasons are longer, and extreme fire weather days have increased significantly in many regions. The impact of climate change isn't a future problem, it's happening right now globally. So far in 2025, every month except one ranks among the top three warmest months on record worldwide. 2025 is on track to become the second or the third warmest year ever recorded. Southern Europe saw temperatures exceeding 50 degrees for the first time. Nobody ever imagined we would reach that temperatures. And this is not just a fire or a heat story. We are seeing cascading climate risks such as floods, fire scars, heat wave, and these all placing severe stress on vulnerable infrastructure, essentially energy grids. In early 2025, New South Wales experienced a massive power outage. That is just this year, earlier this year. Severe storms and damaging winds left about 300,000 homes and businesses without power. The storm severely damaged power lines, substations, and required extensive, difficult repairs. Victoria's AusNet network suffered similar outages during 2024, and that was due to the wind and lightning strikes due to the storm during the storm seasons. And all of this reflecting the growing stress extreme weather puts on aging infrastructure. And that is why grid resilience is now a strategic priority globally for countries. For example, the US is investing about 10.5 billion US dollars in its GRIP program. That is the Grid Resilience and Innovation Partnership Program. And this is being invested for promoting advanced technology, infrastructure hardening, distributed energy resources like microgrid and storage, and predictive analytics for a more flexible and reliable network. The European Unions and 65 countries worldwide have joined global efforts like the COP29 Global Energy Storage and Grid Pledge, and that is committed to modernize grids and boost energy storage to strengthen resilience amid climate threats. So satellite imagery and AI are essential to this whole transformation, and it empowers real-time monitoring, early warning, optimized maintenance, so utilities can act before failures happen. So, in short, climate change impacts are no longer theoretical or distant; they are unfolding now. So, the countries that build resilience into the grid and infrastructure will be the best positioned to protect lives, sustain economies, and secure a safer and smarter future.
Thank you, David. That was very insightful. And I would like to ask a follow up on that. So, given this shift from response to resilience, what do you see as the biggest barrier that organizations need to overcome to truly embed resilience into their operation? Is it technology, funding, internal support, or mindset?
That's such a wonderful question. And I'll say the biggest barrier organizations face in embedding true resilience is the mindset. The technology that we need, satellite data, AI, predictive analytics, asset management, that's already available and that is evolving rapidly. See, funding is always a factor for a business. But when you compare the cost of investing in resilience with the often much greater cost of disaster recovery, the business case becomes extremely strong. There is data that shows for the every dollar invested in resilience, an average $4 is saved in future disaster recovery cost. So that itself is a compelling ROI. So organizations that proactively invest in resilience through infrastructure, upgrades, digital modernization, risk management, they experience less downtime and disruptions. And that translates into millions in saved cost. So compelling ROI is never an issue. What truly makes a difference is how leaders and organizations think about resilience. It cannot be treated as an add on or afterthought. Resilience must be embedded in the culture, it must be embedded in everyday planning, decision making, operation, and it has to be part of the corporate strategy. So, in summary, technology and capital matter, but the greatest hurdle, and while I say the greatest hurdle, it is also the greatest opportunity, is transforming mindset to embed resilience culturally and strategically.
Sure. Thank you, David. So we'll move on to Anthony. So Anthony, we talk about the growing risk to infrastructure. So how does satellite imagery help us to see and respond to those risks more effectively?
Yeah, thanks, Ushval, for the question, and well spoken, David. So, as you've both discussed, network resilience, vegetation risk, and asset visibility are all under growing pressure. While LiDAR has long been a trusted source of high accuracy elevation and asset data, satellite imagery marks a new layer in network intelligence that's rapidly expanding what's possible in network monitoring and risk management. So, what does satellite bring to the table? So, satellite imagery offers significant value due to its broad coverage, its consistent revisit rates, and its ability to capture environmental and infrastructure change over time and also retrospectively back in time. So, unlike traditional inspection methods, satellites can monitor vast and remote areas without the need for physical access. This is a game changer for utilities and transport networks spread across challenging terrain. Modern satellites provide multispectral and hyperspectral imagery. They're seen beyond the visible spectrum, and this enables vegetation health monitoring, identifying stressed or dying vegetation that could become fuel for fires. Land use classification, understanding how urban expansion or deforestation may be increasing risk exposure. And post-disaster assessment, quickly evaluating damage to infrastructure and natural assets after an event. So, for example, during wildfire events, satellite imagery helps emergency services track fire progression in near real time. It's guiding evacuation routes and resource deployment. And then in the aftermath, it's used to assess vegetation regrowth and plan restoration efforts. In addition to wildfire monitoring, satellite imagery is being used to track urban heat islands, monitor water levels in reservoirs, and even assess soil moisture for agricultural planning. These applications show how versatile and powerful satellite data can be when integrated with other sources. For instance, one transport authority we've worked with has used satellite imagery to identify erosion risks along their rail corridor after heavy rains, and this helped them prioritise inspections and avoid potential service disruptions. But satellite imagery also has limitations. This includes a lower spatial resolution compared to aerial or terrestrial capture. It's susceptible to cloud cover over other optical sensors and has a lower accuracy for precision measurements. This is why an integrated approach is so important. When we combine satellite data with other sources like LiDAR or ground sensors and AI models on top, this creates a more complete and actionable picture.
Sure, sounds interesting. Thanks, Anthony. So we understand that satellite imagery clearly has a value, but then it seems integration is key to unlock its full potential. So would you be able to explain how combining it with other technologies like LiDAR enhances network intelligence?
Yeah, absolutely. So LiDAR has long been a trusted tool for capturing high precision elevation and structural data. It's ideal for identifying defects and clearance risks. However, its impact grows significantly when combined with satellite imagery. It adds a new layer of insight that enhances the scale and the situational awareness we can work with. So with satellite data, we're not just seeing where something is, we're also seeing what's changing and why it's changing. So by combining satellite insights like NDVI, which shows the vegetation health, or thermal imaging for heat anomalies, with LiDAR's precision point cloud, we can pinpoint areas that need attention before the problems occur. So the fusion of LiDAR and other data sets with satellite imagery allows us to detect early signs of vegetation health and fuel load buildup, track asset proximity to emerging high-risk zones, gain near real-time visibility ahead of climate events, and prioritise inspections and maintenance based on dynamic risk profiles. So what makes this especially valuable is the frequency and scale of modern satellite coverage. Satellites now recapture and provide updates every few days across wide regions. And this offers a level of coverage that just wasn't possible before. This means we can move from a reactive to a proactive asset management. Looking ahead, the integration of satellite imagery with AI ML models is unlocking predictive capabilities. So we're starting to see models that can forecast vegetation growth, simulate fire spread, and even predict infrastructure stress. And these are based on environmental conditions. And this is where geospatial intelligence becomes not just a monitoring tool, but a strategic asset. Ultimately, it's about seeing through the smoke. So not just literally, but figuratively, to make smarter, faster decisions that protect the infrastructure and the communities as well.
Sure. And one of the questions that comes to my mind is how often can satellite imagery be captured to monitor network corridors?
Yeah, so most commercial satellite constellations today can revisit the same location 1 to 3 days. So that gives us an incredibly frequent view of what is happening along the network corridor. That cadence allows us to spot changes almost as if they're happening, like whether it's vegetation growth, new encroachments, or early indicators of fire risk. What makes this so valuable is then the scale. So satellites don't just capture a single corridor or site. They cover wide regions consistently, which means you can compare conditions week to week, or season to season, or year on year. Over time, that creates an extremely detailed record of the corridor or the area, and it's helping us to see not just what's there today, but then how it's changing. And that shift from static inspections to continuous monitoring is what really enables proactive asset management.
Sure. And what do you think about integrating satellite imagery? How does it help during post-disaster assessments?
Of course, so satellite imagery can play a critical role after an event because it provides immediate regional overview when it's often too dangerous or logistically impossible to get crews or aircraft into the field. So after a storm or floods or fire, so satellites can capture and revisit these affected areas within hours or days. And this is long before vehicles or aerial surveys are clear to operate. What this means for utilities and emergency managers, operators, they can quickly triage which assets or communities that need the most urgent attention. It also reduces the downtime by prioritising inspections and guiding where to send crews first and avoiding wasted effort on the areas that aren't actually impacted. So when you combine this with AI analysis, you can automatically detect damaged assets, map accessibility issues, or even model potential cascading risks. Ultimately, it accelerates recovery, helps the organisations make smarter use of their limited resources in those first critical days.
Sure. Thank you, Anthony. That is very, very helpful and insightful. So once we have all this data from satellites, LiDAR, and sensors, so how do we turn it into actionable insight? What role does AI and machine learning play in making this data truly useful?
I can have a try, Ujval, at answering this one
Sure,
if you want.
please go for it, Anthony. Thank you.
So, yeah, when I think about that, I think about the rapid maturation and the maturity of AI and machine learning platforms that's created significant opportunities for organisations managing field-based assets and critical infrastructure and urban environments. So I think about like current today, organisations can leverage a number of powerful cloud-native AI suites like AWS, SageMaker comes to mind, Google Vertex AI, and Microsoft Azure. And there are other specialized ecosystems like NVIDIA's AI enterprise platform, which is designed to accelerate high-performance data science and computer vision. And also, I think it's used in digital twin applications as well. Together, these platforms enable organizations to scale intelligent decision-making without the need to build everything in-house. And these advances in the space, they're exponential. You know, when we think about AI, that's nothing new. Things are happening on a daily basis. So I think the platforms that utilize these technologies can provide some real value in the insights that can be extracted across combined geospatial data sets. I know I spoke about like satellite and LiDAR, but then you apply this on top. And what we do at Altavec, we embed AI and machine learning into our product suite to help transform complex raw geospatial data into predictive intelligence. So our models are built on the foundation of terabytes of data captured and analysed over more than a decade. And historically, this has been processed in a combination of business rules and then also manual workflows. Today AI and ML, they automate all these tasks. So they provide a smarter, faster, more proactive approach to asset management. Instead of reacting to problems after they occur, users have a more predictive intelligence, I'd say, to reduce risk, optimize resources, create that greater network resilience. So hopefully that answers that question on behalf of Dan.
It does, Anthony, and I think it leads nicely into one of the questions we have received. It talks about how accurate are AI models when predicting vegetation risk or fire impact. Maybe I will give it to Daniel.
Issues. So the AI models, they're great. They're proving to be highly accurate at identifying vegetation health, mapping fire-prone zones, and highlighting the areas that need closer inspection. By combining satellite spectral data with LiDAR, we're not just seeing where the vegetation is and its proximity to the assets, but how it's changing over time using that temporal data and what that means in terms of risk. The strength of these models is in spotting the emerging hotspots and trends across the entire corridor. And the more data we feed it, the smarter and more precise they become. That doesn't mean that managing drift over time and one-off events isn't a challenge and an issue and something that we need to be cognizant of. But the more data we feed into the models with every fire season, every weather event, the model continues to learn, which means the accuracy will only improve over time, and the insights that we pull out decisions will become more informed.
Sure, Daniel. And we have heard that these technologies are very powerful individually. But what happens when we bring them together, and how does an integrated approach change the game for infrastructure resilience?
Yeah, so for organisations managing infrastructure in complex climate-exposed environment, integrating satellite imagery and satellite data with LiDAR and AI is becoming essential. Whether you're responsible for an energy network, a local development, or transport corridor, the value really lies in analysing and providing insights across the combined data set and turning that spatial data into clear, timely decisions. The integrated approach delivers a more precise result, which delivers tangible operational benefits. Maintenance and capital investments can be better prioritised, used more strategically, focusing efforts where it's going to provide the networks greater benefit. Environmental threats, asset vulnerabilities can be detected earlier, which gives teams and organisations greater time to respond to risks before they actually become issues like David mentioned before. If we can add accurate, up-to-date spatial data, organisations become better equipped to meet regulatory requirements and support long-term planning with a lot more confidence. I'll give you an example. With LiDAR alone, we can use AI and ML to identify vegetation that poses an immediate risk to critical infrastructure based on proximity. Once we add the spectral data and hyperspectral data into the analysis spectrum, can now identify the unhealthy trees that if they were to fall during a weather event, are going to actually cause severe damage to the assets. Then we add weather event data, customer data. We can now identify fire risk and the impact to community. We now have the necessary information as an organisation to focus the maintenance spend where it's most needed and where it's going to have the greatest benefit.
Sure, thank you. And I know you gave one of the examples, but would you be able to share some real world examples of how organizations are applying this integrated approach and what kind of impact they are seeing on the ground?
Yeah, so sure, I'll go through a couple of examples, but one of our customer operates 54,000 kilometres of infrastructure, with 60% of that infrastructure running through some of the highest bushfire risk areas in the country. Traditionally, keeping that infrastructure safe and resilient relied heavily on manual inspection, but by integrating LiDAR, satellite, and AI-driven insights, the customers completely changed the game. And the results are starting to speak for themselves. They've improved worker safety by cutting down the need for engineers, surveyors and assessor to physically go into these high-risk areas and difficult to find, locate assets. The accuracy and precision of combining LiDAR with these data sets and AI insights enables desktop auditing through the Altavec platform, saving the business around $500,000 a year in labour cost alone. It's informing budgetary decisions such as forecasting and maintenance spends activities. So the maintenance and preventative maintenance spend is prioritised where they're going to provide the organisation and the community the most benefit. But where it really gets exciting is as renewables flood into the grid, it's laying the foundation for smarter, more informed network design, where operators can plan, model, and adapt in near real time the designs that they're putting out there. Another exciting example, an area that we're exploring, is how the Altavec platform can use AI and machine learning to transform field-based asset management, particularly for rail infrastructure space. We already have a platform and a use case in that, but the pilot we're currently looking at is detecting critical rail assets and defects, things like bolts, clips, joints, broken sleepers, and using high-resolution video and imagery, processing that data at speeds that we've never seen before. So targeting sub 20 millisecond latency per frame. And this can be achieved by running parallel workers. So defects are flagged in almost real time. We moving from our detection to prediction by clustering defects across a network. We can start highlighting patterns and enable predictive maintenance before failures occur. So I think this is in its early stages, but if it's successful, which the results as we're seeing them at the moment are great, this opens the door for a whole new way of working. Imagine an assessor, a reviewer sitting there saying, show me all the broken clips within sleepers in the last 10 kilometers, and the system going and retrieving that data and putting that in front of a user to actually assess and confirm. By combining vision language models with large language models, reviewers can navigate thousands of hours of video and imagery effortlessly, focusing only on the defect highlights. This not only reduces fatigue, but will also accelerate decision making. Together, the technologies position our platform as more than just a detection system, but really moves it to that predictive, intelligent infrastructure management tool. We can not only see what's wrong now, but we can anticipate what is likely to go wrong next. This is a game changer for safety, reliability, and cost efficiency. The benefits are simple but powerful. Faster insights, safer operations, smarter resource use, and ultimately a more resilient network.
Sure. Thanks, Tinian. And I think that's a great segue into another example. Anthony, I know that you have worked closely with the metro rail networks. What have you seen in the rail customers?
Yeah, thanks for that question, Ujjwal. And yeah, Daniel, couldn't agree more. So what comes to mind with an urban metro rail corridor that we've got in Australia, they've seen efficiency gains in their critical infrastructure, where in years past they've had a heavy reliance on manual inspections. So we've helped them through step changing their operations and introducing automation and AI to drive efficiency and precision when identifying risks on their network. So since developing this, they've seen benefits from improved safety across their network. Because we've taken people out of the dangerous rail corridor and replaced this with computer vision, you just have people that aren't in these dangerous spaces anymore. That's a direct impact that we're seeing. We're also seeing improved visibility and coverage and insights of these assets along the corridor. And the computer vision is aiding office workers and minimizing the fatigue that they have doing repetitive tasks. They can spend 8 hours in front of a computer just reviewing imagery. If you can bring AI and automation into that, they could be put on more selective things. And then also we've got a really rich library of assets and risks that can then drive further automation and further precision over time, training more AI and ML models. So for the customer, this means that they're better informed, they're keeping their staff and the community safe, they're maximizing the performance of their teams, and again, a more resilient operation and network. So the integrated approach with AI provides this efficiency, this repeatability, and then also, most importantly, the confidence that their critical infrastructure is performing at its peak.
And what are some of the benefits for the customers, Anthony?
Yeah, I can't reiterate enough the improved safety. It always comes down to safety. So with the workers not needing to enter the dangerous corridor where these vehicles, there's so many tons. If you take them out of the danger zone, it's only a good thing. I think about better visibility and insights. And then with the computer vision, I just mentioned this just before, getting those office teams to focus on the higher value tasks, and we can leave the AI to all the repetitive tasks that they can do in parallel, as Daniel said, and they can do very efficiently. So you get them churning on all those critical things, and then leave your real people and your office teams on those higher value tasks.
Sure, Anthony, and that's a great example of how AI is just not a tech upgrade, but it's a workforce enabler. And now, after discussing all the real-world advantages, there are some questions that often come to my mind. And David, I would like to pose this to you. So one of the questions that I think is very important is, what are the cost implications of this integrated approach?
Hey, Ujjwal, so thank you for that. And when satellite data analytics are shared across departments, so the point is about democratizing the data and sharing it across department. The cost is spread and unlocking of value at multiple level happens. So between emergency response, routine operation, vegetation management, and all of that. So making that integrated approach a smart investment is important, and that pays dividends in resilience and cost saving. So the underlying point here is about sharing it across departments, because this data can be democratized and a single capture can be used for multiple different use cases.
Thanks, David. That's reassuring. And what would you say to a council or a mid-sized utility that thinks that this kind of tech is just too advanced and out of reach, or maybe big on the cost for them?
Yeah. No, that's a great question. Yeah, absolutely. If you ask me about 10 years back, this was for the big boys, right? But the good news is that this technology is so much more accessible than ever. And with cloud-based platforms and scalable data services, councils and utilities of all sizes can benefit without needing to own satellite or build complex in-house systems. And there are cloud solutions that provide shared access to high quality imagery, satellite imagery, and AI powered analytics, and reducing upfront cost, and also making it cost effective for smaller organizations and teams within the organizations itself to use. So you don't need a specialist organizations to come and help you consume this data.
Sure. I think this was very, very interesting. And thanks to all of you. We have covered a lot, right from satellite imagery to AI driven insights. And what I think is what ties it all together is the shift from reactive to proactive approach, and from seeing the problem to predicting it, and from isolated data to bring an integrated intelligence. And such powerful examples of how special intelligence is transforming our approach to resilience is very important. So, people in our audience, if you are in government, utilities, transport, or infrastructure, this is the moment to start embedding AI powered spatial data into your planning, operations, and response protocol. And Altavec is here to help. Whether you're just starting out or with the satellite data or ready to scale predictive models across your network, we would love to connect with you. So now let's open the floor to questions. Please drop them in the chat and we'll try to address as many as we can. While we wait for questions, one of the questions I had seen earlier was, can satellite data detect hazardous tree or falling branches near lines? Maybe Anthony, would you like to take this one?
Yeah, sure, Ushval. So, can satellite data detect hazardous trees or falling branches near lines? So power lines. I assume the question's aimed at. So not directly would be my answer. I'd go with a combined approach. So, like satellite alone, when you think about the resolution, it's going to give an approximate answer. Like it can see things like tree shadow, it can see relative proximity to lines, but I'd be using the satellite imagery to provide sort of vegetation health indices like NDVI or some of the other indices, and then combining that with the LiDAR and using the precision of the LiDAR to help identify how close are the trees, and then the satellite imagery is giving me that extra subjective view of these trees, to identify if they are stressed, or are they in a growth phase, or are they somewhere in between? Is it a dead tree? They also could be a hazard because they're at risk of just falling on the lines rather than like a branch falling off or something growing into the network. So I think the combination is the right option. Satellite just won't have the resolution that you need, and LiDAR, although quite accurate, it doesn't have that subjective information of tree health or tree vitality that you need.
Thanks, Anthony. And maybe another one to Daniel. What's one innovation or trend you're seeing having an impact in the satellite AI space over the next 2-3 years?
Sorry, team. As David mentioned, this technology is more accessible now than it's ever been before. So I think we'll see a larger uptake across different sectors and businesses, and it'll become more commonplace. Towards the back end of that 3 years, this technology is evolving at an exponential rate. So I think even though these data sets are large and we're getting actionable insights from them now, I think it'll get to the stage where we're actually receiving real-time alerts, and that will just become the norm across industry and different sectors.
And how do you ensure data privacy and compliance when using satellite and AI technologies?
Yeah, I think look, our platforms has data privacy built into all its workflows, and I think most modern platforms do that and do that well. But we use anonymized data sets, and we comply with all regional data protection laws. Most AI models are trained to focus in this geospatial space, are trained to focus on the infrastructure and the environment, and really not personal data. So I think securing this data is really just built into the platform.
Sure, thank you. And probably to you, Tony, what kind of training or skills are needed for teams to adopt these technologies effectively?
Yeah, so what type of training or skills? So probably start with the most complicated one, AI, and it's so much more accessible these days. So most teams don't need deep technical expertise to access. We've got Copilot, we've got ChatGPT, and there's much better access to all sorts of AI. Obviously, you need partners to partner with to unlock more and more, and that's probably the same with LiDAR and satellite imagery. They've been the three macros we've talked about today. So yeah, with these intuitive platforms and guided workflows, even I think field teams can use AI-powered insights. So Altavec offer all sorts of onboarding and training to help teams get started quickly, whether that's just with geospatial data or AI plus geospatial or sort of any combination. We can help those teams get started quickly and then they're on their way.
Sure. And there is one more question in the chat. It says, what future advancements or innovation in satellite technology and AI do you anticipate will further enhance network resilience?
I've got a view on that. Do you, David?
You go ahead. I'll add to it. Please go ahead.
Yeah. So first thing I think about with future advancements for AI is, like, we all know large language models, and Altavec's been working a lot with computer vision. So that's taking imagery or video and analyzing it for things that have changed. Something that I've come across recently is a visual LLM. So the large language models that we know, like ChatGPT, etc., you ask it questions and it gives you feedback, answers your questions, etc. This can be done on visual data sets, so video and imagery, and you can start to ask it questions like, what can you see in this image, or find everything in this. I think Dan spoke about this, like, I think it was a sleeper example. So I think that's going to advance quite quickly when we're quite adept as society starting to do prompting and prompting AI, and adding this visual element, we'll be able to ask the AI all sorts of detailed things about what's in a video feed, if it's front of train, or you could even go into aerospace like that, or taxi information. So you've got all these video feeds, and this go into like a legal sense as well, and you could start to look through troves and troves of data and use the visual LLM to extract out that information.
Sure.
I'd like to add to that as well. Also, we are partnering with, a startup, for example, a couple of satellite companies, one specifically a startup here in Australia, right, who is launching a satellite very soon. And what we're seeing is that satellite is getting smaller, faster, and smarter with onboard AI, enabling real-time data analysis. So large constellations in low Earth orbit will provide constant, reliable coverage everywhere. And laser links will make communication quicker and more secure. Direct satellite to phone connection, for example, your new iPhone is going to support that too, will expand coverage without extra equipment. So these advances in the whole satellite world will give utilities faster and better information to strengthen resilience. So I would seriously ask companies and people who are in this field to be looking out to advances on what is happening in this whole world of satellite.
Thank you, Anthony and David. And David, I would like to ask another question to you. So can this technology be used for flood risk or other climate events?
Oh, absolutely, absolutely. While we've been talking utilities specifically from a grid perspective, but the beauty of geospatial intelligence is its broad application across many climate risks. The same satellite data, right, LiDAR and AI models we use to predict and manage bushfire risk can also be applied to flood mapping, storm tracking, and drought monitoring. So, yes, there are multiple different use cases for industries, for insurance, for government agencies that can leverage this.
Perfect. Thank you. Just looking for any other questions left open in the chat. Give me a second. Just have a look. I think we have responded to most of this. I'm just scrolling down to see if there are new questions. I think we're good on the questions. So, anything else would you like to
I
share?
think
Any of the
Ujjwal, there is some questions coming up in the chat.
Sure.
Yeah, yeah. Yeah, I think the points about training, uh, like Tony touched upon, there is from a training perspective, I think these things are very intuitive nowadays. So, even department can still use it. They don't need specialized geospatial departments to manage this. So that is one thing. And then I think I would also like to emphasize the point about the advancements in satellite and satellite technology. Yeah.
Sure. Thanks, David. I think we don't have any more questions. So that's all we had for today. So I would like to thank all the speakers and everyone who joined us live. For any follow-up questions, feel free to reach out to us or visit our website at altavec.com or connect with any of today's speakers directly on the LinkedIn. And don't forget to follow Altavec for more insights on geospatial intelligence, AI, and building future-ready networks. Until next time, stay safe, stay resilient. Thank you.